Okay, Kellen and anybody else? Just Kellen? This is the last half of chapter 5 review. We're on number 8. We're working like back to front. We did the other page the other day. Here is the table for a loaded dice. We said that this one is showing up more often because it's loaded. So if these were showing up with equal frequency and I was doing the average, right? The average would probably live right in the middle, right? Like 3.5. It would be right in the middle of my table. But where's my average going to get pulled? Towards 4 and 5, right? Because this 6 is so heavy, right? This is weighted more. So my average is going to get pulled down this way. So my average might, instead of being 3.5, it might be like closer to 4 or maybe like 4.2 or something like that because that 6 is weighted so heavy. How do I find the average of a table? On your yellow sheet, we did that in section like 5, 1.
You multiply them across.
Multiply them across. And then you add them all together. So multiply that across is 0.14. That's 0.32. That's 0.36. That's 0.56. That is 0.65. That is 1.86. I don't know if that's right.
Those are correct.
Those are correct. And if you add them all together, you get? Have we done that yet?
3.9.
3.9?
Or 3.89.
3.89? I figured it'd be higher than that. But that's reasonable-ish. Yeah. We knew it was going to be closer to 4. I figured it'd be above 4, but that's fine. No big deal. Find the average. Do you see how we like guesstimated that? Okay? Like I would definitely like look at your mean and like, does that seem reasonable? Your mean should live between these guys, right? He should live somewhere there. And look at where he's being pulled, right? Like which frequency is the highest? Good, good. All right. That was just mean, right? That was all we had to do. All right, 7. The Mars Incorporated claims that 20% of M&M candies are orange. We're actually going to do this. This is like one of the first things that we do when we come back from Christmas break. But we do it with Skittles instead of M&Ms. And we talk about like the number of blues that you get and the number of, is there even blue Skittles? The number of greens you get and the number of yellows you get and the number of reds and the number of purples and the number of orange and all that stuff. And then we crunch numbers. And it's actually kind of a fairly long project that you do with your Skittles.
The first day we get back.
That's fine. That's fine. It won't be the first day. It'll be like the first couple weeks into coming back from Christmas break. Okay, so 20% are orange. 20% equals orange. Okay, I'm gonna guess that that's gonna be a P. A sample of 100 candies are randomly selected. Find the mean and the standard deviation for the number of orange candies. Okay, so we want to find mu and we want to find the standard deviation, and we are given like an N. An N is 100, and we're given a P, which is probably 0.2, right? Okay, so we're given an N and a P. How do we find the mean and the standard deviation if that's what we're given?
Wait, why are we going backwards?
I don't know.
We've been doing that the whole time.
Go to your yellow sheet. You have 3 different ways of calculating mean, 3 different ways of calculating standard deviation.
Mean is n times p.
N times P, that sounds good. And standard deviation is, I think it's like the square root of NPQ. Okay, so 3 different ways of calculating mean. Figure out which one is useful according to the information that you're given. N times P is the average number of orange. So if I have 20% orange and 100 orange, that would be 20, right? I should end up getting 20 orange candies with a standard deviation of, I don't know, the square root of 100 times 0.2. What's Q? 0.8. Okay, so this guy would end up being 0.16, right? And 100 times 0.16 is 16, and the square root of 16 is 4, so an average of 4. Now, they could ask you, I wish they would have, because those are nice numbers. The average number is 20. So what would be considered a significantly high number of orange M&Ms in your pack? And what would be considered a significantly low number of orange in your pack? If you add and subtract twice, this would be 28. And this would be, what, 12? Right? So is 12 considered low? No, that's where the cutoff is. Anything lower than 12.
Yeah.
So it would have to be like 11. Does that make sense? Okay. 12 is in the range. 28 is in the range. So anything higher than 28. So it would have to be like 29 in order to be significantly high. Make sense? Okay, what are you doing? Don't do that. Do your math. Yeah. Don't do that. Okay, here we go. 6, find the standard deviation. For the binomial distribution, they want us to find this guy and, which, blah, blah, blah. They give us N and P. How do I find standard deviation?
Square root of NP.
Yeah, this is the same as what we just did. Square root of NPQ. N is 38. P is, I don't like P. What's 2/5? 0.4. What's Q? 0.6. Okay. This is 0.24 if you want to do some math in your head. 38 times 0.24 and the square root of that. Standard deviation.
3.02.
3.02. That's the standard deviation. Standard deviation. Okay. This is boring stuff. Number 5. Find the mean for the binomial distribution, which has the stated values N and P. Here is N, here is P. Find the average. So 70% of my 676 Skittles are doing something. What is 70% of that? What's the average? N times P, or 676 times 0.7, which is, I don't know how much.
473.2.
473.2 is the average. That was too fast. Are you kidding me? We just have the same numbers all over and over again. What the heck? Okay, find the standard deviation. There's N and there's P. How do you find standard deviation? Do you have it in your brain yet? Square root of NPQ. According to the information that we were given, we're using that formula. So 503 times 0.7 times 0.3,
10.2.
and the square root of that, 10.28. There you go. Boy, you better know how to do that. If I give you that many on the test and you screw those up.
I hope you do.
You hope I do?
Yes.
Yeah, that'd be real nice. Unless you don't know what you're doing, then you miss all 5 of them, right?
I definitely know what you're doing if this is something you were doing.
Okay, in a certain town, 22% of voters favor a given ballot measure. 22% sounds like a something. That sounds like a P. I'm going to guess then Q is maybe 0.78. Okay, for groups of 21 voters, that sounds like an N. Find the variance. Ooh, how do you find variance? Given that information. Yeah, it's the standard deviation squared. So if I take this formula and I square it, it's just NPQ, not the square root of NPQ, right? That's not bad.
It's mu, isn't it?
That is for poison. That's for poison. Yep, good question.
3.8.
What?
3.604.
3.604, and that's without square root?
Yeah.
Okay, that's a variance. If they ask for standard deviation, then you take the square root of that, right? Okay. Match the following. Discrete continuous. What does discrete mean? A discrete random variable. It's countable, right? It's a countable. Okay, countable number. Continuous is like a decimal number that continues. Okay, what is it if it's not a random variable? Not a random variable. Like, how do I know if it's not a random variable?
It's not quantity.
It's a category, not a quantity. It's not a number, it's a label. What? I don't care. Sure. If you want to. Okay, the exact weight of quarters. The exact weight of quarters. Would it be discrete or continuous? You could do the weight to 3 decimals, or to 4 decimals, or to 5 decimals, or to 6 decimals. So that would be continuous. So that's B. Continuous. Shoe sizes of humans. That's interesting.
That's just A,
Yeah.
because
that's
animal
A.
sizes.
No.
Political parties, that's a category.
But shoe size is a category.
Yeah. It's not the
So is
number.
political
It's
parties.
Yeah. Political party. I don't know. Maybe there's 2.
Maybe with-
I would probably take A and C for that. I'm going to say more so C. I think it's more of a category.
But with the
Now.
options, I feel like political parties is more.
When we did measurements at the beginning of the year, we did 2 different measurements for feet. We did shoe size, and we also did foot length. So when we talk about foot length, like in centimeters, that would be a continuous, right? But shoe size, I think, is more of a category. Even though it's a number, it's more of a categorical data. So I would probably take A for that one, just because shoe size is like, it would either be discrete or or not a random variable. I see it more of a category, but if you put A, I probably would still give it to you. Because like they say that it's quantitative data if it helps if taking the average actually gives you important information. So like the average shoe size would actually be a useful piece of information, right? The average shoe size for NBA basketball players is going to be a lot higher than the average shoe size for this class, right? So that does, in fact, tell me something. Versus like the average jersey number. That's not going to be any meaningful data, right? So I would probably take discrete just because, yes, the shoe size does tell me something, but I see it more as a category. I'll go ahead and put or A. Political party, that's definitely C because that's definitely a label or a category. Okay? All right, the braking time of a car, what does that mean?
The time.
How long it takes.
How long it takes to brake, to stop. So if you're going like 60 miles an hour, how long does it take to slow down and stop? If you hit a wall, like 0 minutes or really 0 seconds, right? But if you're like braking, I don't know, how long does it take to stop if you're going 60?
If you like slam on the brakes or if you're slowly.
Well, don't they do it in feet? Braking
Yards,
distance.
I think yards.
But it depends how.
So they don't do it time, they do it like,
No, it's braking
do it
distance.
Yeah.
Yeah.
'Cause if you
well,
slam-
braking distance would be the same as braking time. Like they would both be the
slow
same
down and
section.
stop.
Yeah.
There's your-
I think of like Pearl Harbor where they're doing like the time, like, no, like, hear me out, okay? Have you guys watched Pearl Harbor?
Yeah.
Yeah.
Where they're like trying to shorten the distance of takeoff for their like planes or whatever because they only have so many feet of runway when they're on a boat, right? So like kind of the same thing, but in reverse. You're taking off versus
132
slowing down.
feet.
What?
Average braking time is 132.
132 feet. Okay, that's interesting. That's like a third of 100 yards. So that's like
But how do
that's
they
not that.
measure
But what speed are you going to begin with?
60.
60? 60?
But how fast are you hitting the brakes? That's what I want to know.
You
Is it
slam on
Well, you
Brake.
slam on
brakes?
it. That's the brake. Yeah, the braking
Yeah.
pressure
Okay,
is
it's
the
slamming on the
as much
brakes.
as you can.
Okay.
Continue it.
It's continuous because you can measure to the nearest minute or the nearest second or millisecond or whatever. Same thing with distance. You can measure to the nearest foot. You can measure to the nearest inch. You can measure to the nearest centimeter, whatever, right? So continuous. Good, good? Questions about that? Yeah?
So are we taking this Monday?
Ugh. Yeah, probably. Are you guys going to be okay to take it Monday?
Yeah.
If you get a YouTube review?
If we,
Okay.
yeah, if we get to use it.
Tomorrow we'll play turkey trivia. Is everybody going to be here tomorrow?
Should be.
Okay.
Depends if I sleep
Um,
in or not.
Yeah, that's why I'm kind
I
of
might
like,
have to like
whatever.
skip school and just sleep. But
You think so? Okay.
we'll wait here
All right.
till-
Goodbye, Kellen.